Hi students, welcome to the video lectures of software engineering. So today we are going to talk about mapping the data flow diagrams into software architecture. That is mapping DFDs to software architecture. So this concept is very crucial uh, in order to since there is a transitioning that's happening from the data flow diagrams to an implementable software architecture. DFD. Crucial concept as crucial concept for transitioning from data flow diagrams DFD to an implementable software architecture. Okay. So now what does it do? It converts data flow diagrams into well-defined software structure. The call and return structure is commonly used for this purpose. So this approach is often referred to as structure design, which smoothly transitions from the data flow oriented analysis model DFD to a software architecture. Okay, right. So next, what are the types of flows in data flow diagrams? So there are two types of flows. Okay, so first one is transform flow. Next one is transaction flow, we say. So what is transform flow? So this, the data enters, gets transformed, that is processed, then exits. Okay. So the structure is like incoming flow, transform center, and an outgoing flow. Okay. Then use case, when data moves sequentially through the system. What is the goal? So goal is to identify where input becomes output after a central processing step. This is transform flow. Next one is transaction flow. So the transaction flow definition is a single input triggers different paths based on its type. The structure is transaction center, multiple action paths. Then use case is menu driven systems, command interpreters. So these are all the use cases for transaction flow. So next we see the transform mapping for transform flow. Okay. So used when data flows sequentially through a central transform. So then what are the steps? So steps are first one, review the system model. That means we are the context diagram. So we understand how data enters and exits the system at the highest level. Second point is refine the DFDs. That is, we break down the processes into more detailed sub processes. That is how we refine the data flow diagrams. Next, third step is to identify transform or transaction flow. So decide which flow type is dominant. Okay. Next point, isolate the transform center. So where mark the boundary between incoming data processing and outgoing result generation. Fifth point, first level factoring, also called top level architecture, where top modules handle control or decision logic. Lower modules handle input or output and processing. Third is results in a call and return architecture. Sixth point, second level factoring. Map each bubble or process to software modules. Then move outward from the transform center to map input and output processing. Last point is refine using heuristics, where we improve cohesion, reduce coupling, and ensure modular independence, and apply practical judgment and requirements. Then transaction mapping for transaction flow, used when one input can trigger multiple processing paths. So what are the steps here? So again, there are 7 steps, which is similar to earlier one. Review the system model. Okay, then refine the DFDs and identify flow characteristics. That is, define both transaction and transform flow regions if present. Then identify transaction center. This is the decision point where action paths branch out. Then map the transaction structure. Map incoming path like transaction flow, transform flow, and create a dispatcher module at the transaction center. And each action path becomes a subordinate module. Then factor and refine each action path. Use transform or transaction mapping within each path as appropriate. Next, seventh point is refine using design heuristics. That is, which is very similar to your transform. So understood. So when we talk about this transaction flows, okay, where the information enters the system along path that transform external data into an internal form. Okay, so in transform mapping, where step one is to review the fundamental system model. Okay, then step two would be review and refine the DFDs for the software. And in third step, we determine whether DFD has transform or transaction flow characteristics. In step four, we isolate the transform center by specifying incoming and outgoing flow boundaries, which means usually incoming and outgoing flow boundaries are open to interpretation. Okay. So this is what we are talking about. Okay, transform mapping, right? So already I told you, transform mapping is a set of design steps that allows a data flow diagram with transform flow characteristics that are to be mapped to a specific architecture style. Okay, so to map these DFDs into architecture, we have couple of steps. So these are the following are the steps what we have discussed so far. That is, it will review the fundamental system model, which means the fundamental system model or the context diagram. When I say context diagram, it can be level 0 DFD, which depicts an operation in the sense a function as a single transformation representing the external producers and consumers of data that flow into and out of the function. Right? And in this next step, we review and refine the DFDs for software, where the information now obtained from the analysis models is now refined to producer greater detail. That means the process implied by a transform performs a single distinct function that can be implemented as a component in software. Then we determine whether the DFD has transform or transaction flow characteristics. So in general, the information flow within a system can always be represented as transform. However, in this particular step, the designer will select the software-wide flow characteristics based on the prevailing nature of the DFDs. In the next step, we isolate transform center by specifying incoming and outgoing flow boundaries. Okay. So then in the next step, we perform this first level factoring. Okay, so we also called as a top level architecture, where factoring will result in a program structure in which the top level components perform decision making and low level components perform input computation and output work, whereas the middle level components will perform some control and do moderate amounts of work. Okay, then in the next step, we perform the second level factoring. Okay, whereas the second level factoring is accomplished by mapping the individual transforms. We call as bubbles or the process of the data flow diagram into some appropriate modules within the architecture. Like, the second level factoring will illustrate a one-to-one mapping between the DFDs. Okay. So then in the next step, we refine the first iteration architecture using the design heuristics in order to improve the software quality, right? Because a first iteration architecture can always be refined by applying concepts of functional independence. The components are then exploded or imploded to produce the sensible factory. Okay. Most importantly, a structure that can be implemented without difficulty and tested without confusion and maintained without grief. That is what we are going to achieve. Okay. Then transaction mapping. So here in many software applications, a single data item will trigger one of a number of information flows, right? So this data item is called as a transaction. Now there are steps for designing these. So first one is to review the fundamental system model. So which means this step will is identical to corresponding step for transform mapping. Step 2, review the and refine DFDs for software. So a corresponding step for transform mapping. I mean, this is very identical with that. Then identify flow characteristics. Already we discussed this, right? Then map the transaction structure and factor and refine action path and refine the design using design heuristics. So when I say the fifth point, map the transaction structure. So where mapping the data flow diagram in a program structure, which is amenable to transaction process. The transaction flow is mapped into an architecture that will contain an incoming branch and a dispatch branch. Okay. So thank you, students.